Hi, everyone. Thank you for joining today and welcome to our webinar presented by AMPL Optimization titled Leveraging AMPL, Python, and AI to Democratize Creation of Decision Optimization Applications. Your presenters are Bob Forer, President and Co-founder of AMPL, and Filipe, Head of Development at AMPL. Bob is Professor Emeritus of Industrial Engineering and Management Sciences at Northwestern University, as well as President and Co-founder of AMPL Optimization. He has written extensively on optimization modeling and computation and has served as area editor of leading journals in this field. His work has been recognized by the Informs Impact Prize and by election as a Fellow of Informs. Filipe is Head of Development at AMPL Optimization, where he oversees and/or leads most software development projects. He has a PhD in computer science with a thesis on integer programming models for cutting and packaging problems, which are currently being used in industries worldwide. After the presentation, we will remain live for 15 minutes for questions. Feel free to submit questions via the Q&A function in Zoom, and we will ask them at the end of the presentation. And now I will turn it over to Bob and Filipe.
Thank you all for being here. So today we are going to be looking into what AMPL, Python, and AI can do to make it easy to build decision optimization applications. This is the outline for the presentation today. I'm going to start by looking at the title and why AMPL, why Python, why AI, and also talking a little bit about the risks of AI. Then there is going to be the part that you are probably looking forward to is the demo, which in fact are going to be 3 demos. Following that, I'm going to briefly mention some scientific research that is happening in this area and show some learning resources to get started. Then in part 2, Bob is going to talk about another thing that we do to lower the modeling barrier, which is automatic reformulations that allow you to express your models in an even more natural way and let our solvers take care of automatically rewriting that in a way that works so that you don't need to have all that knowledge and you can just express the models in a way that is natural to you and matches the business problem description. And finally, there are going to be some demos of real-world applications built using AMPL, Python, and AI, at least 2 demos, depending on the time left. So let's start. Why AMPL? In one word, I will say efficiency. Because it allows you to write models efficiently. You can just express your problem there. It is fast. You don't need to worry about writing your code in a different way to make it more efficient. In most of the cases, you can just express it naturally. Also, it allows you to quickly validate your models. This is particularly important if you are going to be using AI to generate models for you. If you are making decisions worth millions, it is important that you don't have a plus instead of a minus somewhere in the middle of your model. So this is one very important feature. And another thing is the ability to send efficient models to the solvers. So our solver interfaces, they adjust your models based on what each solver supports so that the models are sent in the most efficient way possible. And also your formulation can be adjusted according to what each solver supports. This is also going to be mentioned in part 2. And finally, you want to be able to instantiate huge models without having to worry about efficiency, about code efficiency. This is particularly important in Python, where often people are forced to rewrite the code in a less readable way, further away from the original problem description, in order to gain some speed. With AMPL, usually you don't need to worry about that because you can just express your problem naturally, send the data in, instantiate the problem in AMPL, send to the solver, and then retrieve the solution. So why Python? Everybody knows why people pick Python these days. So this vast ecosystem is the main reason. There is a lot for data preprocessing, solution analysis, and visualization. And another thing that is quite important is it integrates really well with AMPL. The Python data types, they match quite naturally sets and parameters in AMPL. So that is something that makes this integration quite powerful. This is what happens when we combine AMPL and Python. So in here we have the Python ecosystem, just a small part of it. And here we have AMPL. And in AMPL, we have the connection to the best solvers out there with the best interfaces out there. Because with ours, when you are using the solvers via AMPL, you are able to do things that the solvers natively cannot do, as you are going to see. And also another thing that you get is the ability to then deploy anywhere. So the ability to deploy on any cloud provider locally or any kind of environment that you may wish to use. Now, why AI? So people are already quite aware that AI is quite powerful for generating code. So that is one well-known feature. But for optimization, it also has several use cases. One use case in particular is, for instance, you are in a certain industry and you might just want to know what kind of problems can you optimize in that industry. And quite often these problems, they in research papers and in different areas and different countries, people call them different things, but they are the same. But you can ask, okay, in this industry, what are the problems that people usually need to optimize? And then for a particular problem, you can ask, okay, what are the complications that arise in practice? That kind of question is something that you can use AI and in particular ChatGPT for. Another thing is sometimes you forget something in the problem declaration, and you can get ChatGPT or some other tool to tell you, okay, this is a type of constraint that is often included in problems similar to what you asked me to write. And this last point is the main and most common uses. Essentially, you can ask to explain a model, improve a model. Let's say you have a model with bad variable names, like short variable names, and you want more expressive names, you can ask for that. You have a model made in some other tool and you want it translated, you can ask for that. So these are some use cases for AI in optimization. And in terms of risks, so we have been using generative AI for quite a while, since before ChatGPT. I was already using GitHub Copilot way before ChatGPT. And I was even ignoring ChatGPT during the first few weeks. I was assuming, okay, this is just hype. It cannot be much better than what I'm already able to do with GitHub Copilot. But it was a big surprise to me. It is a lot more powerful, but there are risks. You need to understand the topics because you need to validate the outputs. It looks always quite confident, but it might be confident and wrong. So you need to be able to understand that and be able to fix it. In particular for optimization, you need to make sure if it produced an optimization model for you, you need to confirm, is this model correct? And in here is one thing that AMPL helps, is that the model is expressed in a way that is so clear that is often easy to validate and to see if there is anything wrong with it. Another thing is you might not be able to go back to the times where these type of tools are not available. For instance, if ChatGPT is down, I don't even try to do what I will do when it is working, because I will be so slow compared to how fast I am when it is running, that it is not even worth it. And this brings also to this last point. Either you really start using generative AI effectively, or you might really have a lot of trouble competing with anybody that is able to do so. So even if someone has a very, very high level skill set, they might have trouble competing with others that are able to use generative AI effectively, because there is a lot of code that is common, boilerplate code that can be generated really, really fast and is pretty much impossible for people to compete with. There are often situations where it is really necessary to fix things up. Then knowledge is really important there, but there is really a lot that can be sped up substantially using AI. So let's get into the demos. Okay, so the 3 demos that I'm going to go through. The first one was the first time I used ChatGPT 3.5. It had been released just a few weeks prior to it. Then another example for stochastic facility location using ChatGPT 4. And then an entire application built using ChatGPT 4, not just the model and app, but also the idea, and everything was built using AI. So let's start with this first one. So here in Colab, we have this example here. the Christmas model. And essentially, ChatGPT was released a few weeks before Christmas, and we wanted to make a post for social media. And we did not have any idea of what kind of model could we write. So I was playing around with ChatGPT, and I decided to ask, okay, can you generate a Christmas model in AMPL? And this is the output. And then I also asked, okay, can you generate the description in Matjax to use in a collab notebook? And here is a description in Matjax. And here is the description visually. And here is the model. This is a gift assignment model. There is a parameter for the amount of happiness that each person gets from receiving each gift. These are the assignment variables. We want to maximize the total happiness. There is a cost for each gift, so you need to satisfy a certain budget, and each person needs to receive one gift. This is in mathematical notation, and here is the same in AMPL. You have a set of people, you have a set of gifts, a parameter for the cost, a parameter for the happiness, a parameter for the budget, assignment variables, maximize total happiness, budget, and one gift per person. So this loads the model. And how does this integrate then with Python? So with Python, you can just load the data as easily as this. So for the set of people, you can just have a Python list. For the set of gifts, you can again have a Python list. It could also be a set or any iterable. For the parameter cost, here we have a dictionary, but it could also be a pandas data frame or series. For the budget, it is just one value, so you just assign the value. And now for the last parameter missing is happiness that has two indices. This is one way that you can have a pandas data frame with this data. So one index here and another there. Or you can have a multi-index like this, and here the values. But it really does not matter. You just assign one way or the other is the same code. Then you pick one solver to use, you solve the problem. And in here, I'm retrieving data, in this case, evaluating an AMPL expression and asking for the result to be returned as a dictionary. Then going through it to display the solution, changing the budget, switching to Groby, solving again. And this time I'm asking for all the values of variable X as a pandas data frame. And then I'm displaying all the rows in which the value is 1. And you can see it here. And finally, let's change the budget again, change the solver now to CVC, solve again. And this time I'm asking for values of variable X, the assignment variable, as a dictionary. I go through it and display the solution once again. So this shows my first interaction with ChatGPT that produced a very nice model to also show the integration with Python. So this is example 1. Example 2, this is a very recent attempt now with ChatGPT 4. I had been using ChatGPT 3.5 for a long time and quite happy with it. I knew that I had to fix things up quite often, but I was fine with it. But when I jumped with ChatGPT 4, it was again a surprise. It is a lot more powerful than the other one. And in here, I'm asking for capacitated facility location model. In here, I even made a typo, but it did not matter. It understood what I wanted. Here, it wrote the model. So in capacitated facility location, you have a set of facilities that need to serve customers that have certain demands. The facilities have capacities and costs, and you want to decide the subset of capacity of facilities to open. So here we have a model, but I did not like this model because it looks like mathematical notation. And in AMPL, even though things can look like mathematical notation, we can use better names. So I asked, write an AMPL model with more expressive names. So it did so. Here we have a model, the exact same model, but now with better names. We have a set of facilities, a set of customers, the shipping cost from each facility to each customer, the opening cost for each facility, the customer demand, the facility capacity, then the variables for the amount shipped from each facility to each customer, the binary variables that decide whether or not a facility is open. And here the objective, we want to minimize the total cost, which is the sum across all facilities, all customers, of shipping cost times the amount shipped, plus the sum across all facilities of the opening cost times the binary variable that will be 1 if the facility is used. In terms of constraints, we need to satisfy the customer demand. We need to satisfy the facility capacity. And here we have the linking constraints that connect the amount shipped to the binary variables that will be 1 if the facility is used, 0 otherwise. So this is the deterministic version of the model, and I'm not happy with it. Now I want the stochastic one. So what needs to happen for the stochastic version to be created? You need to add another set for scenarios. And one thing that it realized when I asked for the stochastic version, I was expecting just for uncertainty in terms of customer demand, but here it also mentioned the varying shipping costs, which is something that had not occurred to me the first time. And this plays a factor here because the indexing set scenarios now goes into shipping cost and also goes into customer demand, the two parameters that are now stochastic. And here for the shipment, we now index our scenarios, so the amount being shipped in each scenario is going to be different. The is open binary variables, this is the stage 1 decision variable, so it's not indexed over the scenarios. In terms of objective value, we have the sum now across all facilities, all customers, and all scenarios of the probability of the scenario times the shipping cost times the amount shipped plus the cost of opening the facilities. And now we also need to specify the demand across all scenarios, respect capacities across all scenarios, and the linking constraints also across all scenarios. So this is the second example. Now you can see that it is able to model even stochastic problems. Now let's go into applications. So for applications, usually we use Streamlit. And let me just show you one very simple Streamlit app. This is to show how Streamlit works. In here, we are solving the n queens puzzle. We have n queens on an n by n chessboard. We want to place them in such a way that no pair attacks each other. One convenient way to model this is using the constraint programming construct all different, which is not available in MIP solvers. But with AMPL, it does not matter because we take care of that for you. Here I can change the number of queens, and you can see this being solved fast by an open source solver that is linear. It has absolutely nothing from constraint programming, but we generate a very strong reformulation for this model automatically for you. So you can even use constraint programming constructs and without having to worry about how will you have to reformulate this for it to work with that particular solver. Now let's look into the code really quick. So there is not much that you need to know to use Streamlit. Essentially, you need to import it like this. And then if you have, for instance, a triple quote comment in your script, like this with Markdown, it renders like this in the app. Then what we do afterwards, we instantiate an AMPL object, we load the model, we pick a solver, we set some solver options, and then in here we have this ST slider, which renders as this slider that you see here. And every time I change it, is as if I was assigning n to a different value. Then that value is sent to AMPL here. Then we solve and retrieve the solver output to a variable, and we have some code to display the solution, which then produces this and this solver output. And at the end, we have again another comment block that renders as markdown, which is this part here. So this is how Streamlit works. Now let's see an entire application built using AI. So this year at the analytics conference, we wanted to do an AI demo there. And one idea was to try to copy the Groby burrito game. So we wanted to do something similar, but still slightly different. We end up with this game in which you pick a park in Disney World, you pick restaurants or cafes, and then you get a list. For instance, in this case, all the restaurants in Epcot. And in this table, you can see the restaurants, the rating that they have on Google, the number of reviews, and a rent estimate. Then the objective is to maximize the total number of reviews used as a proxy for popularity and ensure that the average rating is above 4. I'm going to pick a few of them randomly. So imagine that you are making decisions just looking at an Excel spreadsheet without using optimization. And this is the amount of money that I will spend for selection that I picked. Here we can see the restaurants being displayed on a nice map that you can focus in different locations and so on. So this is the budget. And here we are giving the same budget to Groby. So this is the budget that we are giving to Groby. Groby found a solution with this amount of total reviews with an average rating above 4 like we needed. How does this compare with the solution that I picked in the beginning? So I had the same cost, but a lot less reviews and a better average rating, but the objective was here and it was missed by quite a bit. Here we have the Groby output where you can see that it solved the problem really fast. And here we have the problem description. You can see it's written really nicely. It was not me, as you are going to see soon. And here a model, the model that we are optimizing. We have the set of restaurants, parameter for the cost of each restaurant, the ratings, the number of reviews, the budget that we have available, the binary variable that decides whether or not to invest in a certain restaurant. We want to maximize the total reviews. There is a budget constraint. And there is an average rating constraint, which is in fact an weighted average. So it is proportional to the amount of reviews rather than just averaging using the ratings. So how was this created? Move this on here. Yeah, let's go here to the top. So this is the entire ChatGPT session that resulted in the creation of this app. And the idea was not even set from the beginning. So initially I was just asking, retrieve the location of all attractions in Disney World in Orlando. It gave me a code using Google Maps API to retrieve that, and perfectly good code working right away. Then I asked display these points on a map, and it decided to use PyDeck. So this tool that draws these really nice maps, I had no idea about it, but it generated code that worked immediately and was looking really nice. At no point I checked documentation for this library, but it is quite good. Then I asked, okay, generate coordinates of points inside streets inside Disney World. Essentially, here I was looking for something that will give me coordinates where we could put burrito stands. So I tried to suggest some ways to obtain that, but not something that I could easily use for what I wanted. So one other approach, okay, given two locations, let's try to find 10 points along the shortest path between them. It gave me some code using Google Maps, but it was still not exactly what I was looking for. Then in here, I'm just asking for avoiding going into documentation of PyDeck and just asking to put labels on the map like you see them here. And it did so. So these layers with the text layer with labels. Then I went back to trying to find points in the map. And again, it gave me a different approach using a polyline, but it's still not what I wanted. And now I decided, okay, let me try to write a model. So let's say I have coordinates of different points in Disney World, and I want to find a central location adjust to different weights. So let's say we want to find a central point that will be close enough to the most important locations. And it built a model. The model is okay. What was not okay was the problem statement, because I was then told that in Disney World, there are 4 parks, that they are quite far apart. And if I did this, I will end up in the middle of nowhere. So it was not a good approach. So in here, I adjust what I was looking for. Now I'm asking for the location of the 4 parks, the 4 parks that we allow selecting here. And it gave me the code using Google Maps API to retrieve these coordinates. This code is perfect and works. Now I ask, okay, I want the popularity, so, some information about popularity. It could not, what they said is that it could not obtain that type of information because it's not available. Then it occurred to me, okay, restaurants, they have reviews. So I asked for code to find names and coordinates of all restaurants near the 4 attractions. And here is the code. Then I asked, okay, give me also locations of coffee shops instead of restaurants. And here is the code. And now I asked in Streamlit to select with options restaurant and cafe, essentially to allow selecting this. And even though I was here, in fact, just asking for the select itself, but it produced not only the select, but the entire code with the select and also the code to load the coordinates. So it produced everything immediately. So I did not even have to write that myself. Then here I was just avoiding going to the documentation of PyDeck chart. So to adjust the zoom. Now I wanted to get information about how busy the different restaurants are. It could not give me that information. So not an option. And in here, I'm switching to a different thing. I'm just asking for it to help me with something with pandas, which is something that I ask quite often. So instead of going to check documentation, I just ask, oh, how do I do this with pandas? Because in here, I was already working on this table that you see here. And I wanted an editable data frame, which is something available in Streamlit, but quite recent. At the time, it had been released like 3 weeks before. So it told me that it was not aware of it. But it still tried to produce something that could be useful. Then I asked, okay, using the experimental data editor, it already existed for a few months, and I wanted to see if it could use it. Again, it wasn't not aware of it, so it could not use it, which means if it is not available, then I had to really go into documentation and implement essentially what allows this table to be editable. That is the thing that I was asking for. And now here is where we ask for the model. So at this point, we have a table like this with this information. And given data for restaurants, rating and reviews, write an AMPL model to buy a set of restaurants under a given budget such that the average rating is above 4 and you maximize the number of reviews in total. So here is the model, but not in one block. Okay, put the model in a single block. It tried and it managed to do so. And here I'm again asking for help with pandas. So this is a real session that went for 2 or 3 hours, but that resulted in the creation of this app. This is unrelated. Now, write a problem description for the AMPL model. So here is the problem description in Markdown. It wrote it in Markdown, but essentially it wrote the same thing because it renders Markdown, it does not display it. Then I had to tell it, okay, I want to copy it. And then, okay, it put it in a block, but he had some issues here with math parts. So in a single cell, please, and same problem. Then here I was more explicit using Markdown with matchjacks. And now it managed to really do everything correctly. So this part that you see at the end, this description, is that Markdown copied directly from there. And this model is the model that was right about here. Let me go back. So this model is already here. And finally, as if this was not enough, I also needed some ideas for names. So I asked for it to suggest some names. Then shorter names using just 2 words, asking for more options. And just 2 words, but being second one game. And here we finally have the name that was picked. And this was the entire session to create this app in here. Okay. So we have been using ChatGPT for quite a while, but we were not the only ones noticing that. So last week I met a professor that presented at the Euro conference, this talk. And he not only used the ChatGPT and similar tools, he also built a specific RAG just for AMPL model generation, including a verifier. So ChatGPT is a general tool that happens to be quite good at generating AMPL models, but it is possible to build custom tools just for AMPL itself that can include, for instance, a verifier agent that consists of you receive a model from the coder agent, you send it to AMPL, you get the error message, you send it back to the coder asking for it to fix the errors, and iterate like that until you have a correct model. So it is possible to do even better, to build even better tools if you target AMPL directly. For some reason, ChatGPT is so powerful that it managed to do that even without having a verifier. It's still, from time to time, it creates some errors. There are some common errors that we see, but usually quite easy to fix, and it tends to be really, really useful. Now I'm going to just finish my part, just going over some resources that we have if you are starting. So we have on Collab, we have a collection of notebooks, and anybody can contribute here, even yourself. So in case you want to showcase your work, if you built some notebook from for a real world application, you can put it here, and we can put it in front of our customers. If there is a company from that area that is looking for a model, we can show it to them, and they might see, okay, maybe all these people that we have here writing models, they are not good enough, we should hire this guy instead. So it is an opportunity for you to get a job with some of the biggest companies in the world. We have some, here is just one example of a random notebook that we have in there. In here, we have a military application. We have an electric grid, and we want to ensure that it survives to the loss of 1 or 2 nodes, and that in case you lose 1 or 2 nodes, you have enough redundancy to not lose anything else. Then another resource is Mobbook. So contrary to Collab, which is kind of random and people can just contribute, in here, it is a more organized set of examples, organized according to different categories: linear optimization, mixed integer, network, convex, conic, under uncertainty, robust, stochastic, all of that grouped into different chapters. One particular example in there is this notebook that I really like, the recharging strategy for an electric vehicle. And this is an introduction for part 2. So in AMPL, you can write a constraint like this. So this constraint is full of logical conditions. This is equal to this is equal to that, and this is equal to that, or this is equal to this, and this greater than this, and this is equal to that, and not this, and that. So essentially, this is an XOR. So we could just have XOR here and not have the second part. But I like to really show the long logical expression because it is quite impressive to see how complex this can get. And imagine if you had to rewrite and reformulate this yourself to send to a linear solver. With AMPL, you don't need to worry about that. And in particular, different solvers have different ways to receive this. In some cases, you can use indicators. In some cases, you need to use big M. So there are different approaches that work best with different solvers. And we take that in consideration so that you don't need to do that yourself. And now let's go to part 2.
Okay. There we go. So Filipe has talked about application building using AMPL and AI. What I'm going to turn now to is saying some things about the modeling language itself and how that's been made more expressive and really a lot more helpful to do these kinds of applications. And I'll first motivate this by describing some typical user complaints and some developments that got us going in this. And then I'll describe the realization in what we call the MP interface, which gives you the ability to write models more like you think about them in a more uniform interface to a range of solvers. Okay. So here's a typical complaint from a mixed integer programming user. They've written this is some AMPL like you've seen already, and they wrote this constraint, and this constraint is syntactically correct in AMPL, but they got this horrible message from Cplex, it doesn't work. And so we get, this complaint, and what do I have to reply? And what I had to reply was, well, you need to reformulate this so that the solver will accept it, and you should add some more binary variables, and then you should break your constraint into 2 parts. And the second part is actually a kind of logic that was already recognized by the solver interface, but this first part was not, so you have to break that into 2 more parts. So what you end up with is the user wrote something that was actually syntactically correct, but in order to get the solver to deal with it, you had to introduce variables and 3 sets of constraints. And now there are various problems with this. If it doesn't get documented, it's not clear what it's saying. If you need to change the constraint somewhat, you may make a mistake. There are various reasons why you would prefer not to have to do all this. And here's another nonlinear complaint. Someone gets this message from Groby, can't handle it. And so they look and they say, it's probably this. I have it's not quadratic because it has 3 variables multiplying each other. And now, can I linearize one of these variables? Well, not quite. So I have to write back and say, this is a cubic term. And you could conform it to quadratic, which Groby does accept by defining a new variable equal to the product of the first 2 terms. So you have to define all these new variables. You have to define them equal to this product. And now you have a quadratic constraint. And Groby handles that, which is fine as long as you use Groby. If you want to use something else, then you still might be out of luck. And so then you might need to linearize the whole thing. And that gives you these 4 constraints. And notice it looks nothing like what you originally were thinking about. Whereas the original constraint that was rejected was exactly what you had in mind. And so that's one of our big motivations, was to not have to write so many of these explanations. And 2 other developments that motivated us were, first, there's a language called MiniZinc that was designed for a kind of solver that is similar in some ways to the mixed integer programming solvers like Groby and Cplex and so forth. What's called a constraint programming solver it's particularly powerful on certain highly combinatorial or logical problems. And but when people use this language to drive a constraint programming solver, people ask, well, how would it work with Groby? Maybe it would be faster. So they wrote an interface that automated the model conversions for use by mixed integer programming solvers. So basically, you could write the logic that MiniZinc is strong in, and it would convert it for use by these solvers. And the first named author here then came to us and worked with us to describe this MP interface that I'm going to describe. And so so this is one background. Okay, there's someone who had some experience doing these conversions, but now was going to do something much more difficult. The second thing was that in the Gurobi solver, they start adding to their Python interface a lot more kinds of constraints than just the linear and quadratic algebra. So they had all these kinds of general constraints for different kinds and various non-linear functions. And if you're going to have a modeling language that's general and supports a lot of solvers, then it better support these extra features that they have. Okay? We don't actually know what it does when you give it one of these general constraints, and it might change from version to version, but we certainly want to support it. So that also led us to think, what do we have to do for our interface to give this more general support when the solver can provide it? And but this didn't solve all the problems, because the Python interface was limited. So here's an example of a user complaining to Gurobi that they wrote what they thought was an obvious way of using the general max operator to define this constraint. And it gave them this horrible error message from Python. And so they had asked what to do. And they said, oh, well, general constraints aren't, this is the response. General constraints aren't meant to be used this way. And furthermore, it only accepts single variables. So you have to add auxiliary variables and then do this and that. And so that one statement in Python that looked like it should work became all these statements. So again, it needed conversion that had to be made by the user manually. And we wanted to avoid that. So that's the motivation for what we call the MP solver interface library, that it substitutes for our old interface library, and it's designed for recognizing all sorts of problems and syntaxes and converting them to forms that you can, to forms that can be sent to a variety of solvers. And so the general approach, though, was that AMPL actually had a lot of logical expressions that could be written in it. It's just that you couldn't send them to solvers before. So basically, we had the syntax in the language. It was just a matter of writing an interface that could take full advantage of it. And they could allow all those expressions to be used and to use together and to automate the linearization and other conversions. And if it was something like Gurobi or one of these other solvers that actually natively support some logical expressions or some nonlinear expressions, then it should be able to send those directly to the solver. So it should be able to decide for each solver, which things can I actually tell this solver and which things do I have to convert before I send it to the solver. So now to revise this, here's what the user wanted to write, didn't work, but you can write that in AMPL in almost the same way. It's actually a little simpler. And this is now, this you can send to Gurobi, and it's just converted using the max general constraint automatically. So you can just write it the way you thought about it. And if you want to solve it to send to a different solver that doesn't have these general constraints, then our same interface will linearize it instead before sending it to the solver. Okay, now I want to use a little example here. So I'm just say that everyone's probably seen this kind of network flow example where you send products in at the sources and you want to ship them to here at the least cost. And so you want to keep shipping costs low and basically meet supplies and demands and balance at the intermediate nodes and so forth, respect capacities. And you can write, you've seen these AMPL models from Filipe's examples. So here's a model that does that. This is for the multi-product flow problem. Okay, and it's very much like the math. So here's an example of the math. Yeah. Now, what I want to show is how when this becomes more complicated, you really need these new features. But just briefly, I'm going to detour and say, at this point, you may ask, well, why can't I do this in Python instead? Aren't there Python modeling languages like GurobiPy and Pyomo and so forth? And there are modeling languages based on based on Python, and they do everything, including the model and everything in Python statements. And that is seen by some as the advantage, but it's also their big disadvantage because unlike AMPL, they don't separate the modeling and the programming, and they don't separate the models from the data. And by using AMPL to describe the models, we get a much cleaner statement of the models, and this facilitates the development of the models and also the applications and also maintenance of them. And just to give an example, here's a Pyomo description of pretty much the same thing of what I just showed you. And this is just the beginning of it. You can see there's all sorts of data stuff set up. And then you see these rules. Those are actually the constraints. Okay? And this is where it solves it. And so you've taken like the clean model that you get from AMPL has sort of disappeared into all this Python. And that's why we favor using a separate modeling language instead of just doing everything in Python. There are other problems like Filipe mentioned about efficiency and about just Python programming problems that you have to deal with when you're trying to write it properly. So now I'll come back to this. Here's the same example, but it has some complicating logic. You have to decide whether to use each arc. There's a variable plus a fixed cost for using an arc. Shipments can't be too small and there can't be too many arcs used. So now there are three new kinds of constraints. So for example, and objectives, there's positive shipments have to incur fixed costs. So there's a trick to doing this. You introduce a binary variable for each of these arcs, these shipment arcs, and you multiply that times the fixed cost. So you can use the binary variable trick, but what you really had in mind was you just want to sum over every arc. If there exists a flow that's positive, then sum in the fixed costs. And so this is like a natural description that now we support. You don't have to figure out the trick of using the binary variables. And it's the same for the other two things. Shipments can't be too small. Well, you can write it like this. When you don't use an arc, it really forces the flow to be equal to 0. And if you do use the arc, it forces it to be between the minimum shipment and the capacity. So it can't be smaller than this minimum shipment if you use it. But what you really had in mind was the total flow should equal 0, or the total flow should be between min ship and capacity. So now you can just write that. You don't have to use the binary variable trick. And the third one is similar. If you want to say that you can't use too many arcs, you can add up all these binary variables and say that they have to be less or equal to max arcs. But what you really have in mind is that at most max arcs of all these arcs have a total flow positive. Right? Now, if you're familiar with integer programming, then you're probably used to doing these tricks with the use variables, and you might say, hey, they're even shorter, and they're perfectly obvious to me. And of course, this is just a simple example, though. And the thing is that in real applications, okay, the linearization is not so easy. They're much more complicated. So this is the example I showed at the beginning, and that was complicated. Here's a more complicated one even there that someone gave us. So now you don't really want to do this by hand to linearize this whole thing. And here's the one from Filipe's example as well, that, I mean, you could figure out how to do it. You might have to work for a while to get it correct, but now we can just do it for you automatically, and you can write it the way you think about it. Okay. So now I'll just wrap up here by describing all the operators and functions that we've put in here, and you've seen most of them somewhere. If then else's and implies. You've seen some logical operators like LOR and. You've seen the max, which is a simple piecewise linear function. You've seen the at most here, which is one of the number of different counting arguments we give. Comparisons, you've seen all different. You can also use strict inequalities or not equals. And in nonlinear, you've seen where I can multiply three variables together, and we can handle that. And there are a few more that are mentioned here. So, and all these things can be used together. It's not like they have to be used one at a time, and you have to build them up. You can use them in combined expressions as well, as you've seen a few. Okay? So just to conclude, I'll say that all these different MIP solvers have this MP interface. In each case, it uses whatever native features it has. It uses those, and it converts everything else to something that the solver can use. And generates all those conversions. And when it's done, it sends it to the solver. And when it comes back, it's all examinable in AMPL. It actually shows you all the AMPL variables, and you never have to see all the conversions and so forth. So with that, I'll hand it back to Filipe. And
Sorry, I was muted. So I'm going to go over some more realistic examples that we have also on Streamlit. In this case, we have an aircrew training scheduling app, which includes all the details for real airlines. For aircrew training, one of the things that plays a role for airlines is the seniority of people. So people with higher seniority, they pick slots, desired slots for training, and they should have priority over people with lower seniority. So this is one of the main things that needs to play a role in these models. It is common to formulate this using dominance rules, but in here we model it using hierarchical multi-objectives, using this kind of expressions in objectives. And you see that all of this stuff is automatically linearized for you. And this is called a preferential bidding system. And it is common, but it had not been used in this problem in particular, especially at the scale that we used it. With this, our objective was to produce a schedule for over 10,000 trainees. And this allowed us to even identify a bug in Gurobi, because essentially we tried to send initially 8,000 objectives to Gurobi, and we found some memory issues. And we reported the issue to Gurobi, and they had never seen an instance with so many objectives. But the thing is that by using hierarchical multi-objectives instead of dominance rules, we are able to make a model that is a lot faster and able to really solve a very large scale problem of this size. So this is a problem that we could charge a company to write. But in this case, we did it for free, essentially to keep the rights of it and to have a real model to show to the world for people to see how a model for an application, including all the details, is implemented and so on. In here, in terms of the app, you can pick the number of trainees, the number of sessions. The trainees, they are from different roles. They can be a captain, a pursuer, flight attendant, and so on. They can speak one language or another or both. So there are trainings in different languages for the airline in consideration. And we want to schedule them in such a way that everybody, so people, they have to do trainings from time to time. And if they are about to expire and to need a new train, we need to really schedule them. Otherwise, they might wait for a following opportunity. So that is one of the conditions that needs to be met. And another is to assign people to the slots that they desire. Here we have a solution for each trainee, the assigned slot. And here we can see the options that they had. So they had these options. These options will be valid, but not ideal for them. And you can see what was picked. One detail here, let me go up just a little. If you see the solver being used here is ICE. ICE does not support hierarchical multi-objectives, but with AMPL it supports. So we don't only do reformulations, we also do features. In here, you can pick any of the MP solver drivers. All the drivers that do automatic reformulations, they also have automatic new features added. Right now, the first feature is multi-objective, hierarchical multi-objective, and also blended objectives. So you can do both with any of the MP solvers right now. So this is just one of the examples. Let me just compress this. And as the rest of the app is more visualization. And where was AI used here? So you see this nice looking model with nice names. Initially, when it was written by starting from a paper where they use the dominance rules. So we have this notebook that combines not only having our model with the original model from the paper, and also at the end, a performance comparison where we beat the other model. The author of this was in fact the same author of the MP interface. So Gleb Velo wrote this very powerful formulation for this problem. But in here he's using the names in a very similar style to the equations in the paper. So what I used AI for, so I gave to ChatGPT the model and asked, okay, rewrite this, but with better names. And essentially what it did, it picked the comments and managed to rewrite the model using better variable names derived mostly from comments. Then I had to fix up a few things, and that was it. Other than that, like usual, I use it for generating code for creating these various inputs and tables, and how to manipulate the pandas data frames, like you have seen me doing in the other example. Another example we have here, batch processing. In batch processing, you have materials that can be in different states, and then you have units that are going where materials can be put in order to perform some reaction. And from the reaction, there might be one or more materials that are produced that are then stored into a different state that can then, again, in a following time bucket, be moved to an unit to process and so on. And at some point, you end up with some products. So one user contacted us that they were trying to model this. They had seen a Pyomo model for this, but they were struggling extending that model to support what they needed. So what I did was in 2 hours, I took the original example in Pyomo and asked ChatGPT, okay, rewrite this in AMPL. And 2 hours, not just to rewrite the model, essentially to rewrite also the entire notebook. And rewrite it and fix the few details that it had missed. And we got a working model in AMPL that I could then easily put in an application like this. So here you can see the various type of controls that we have, the time horizon for the number of time buckets that we have, the various states and the capacities for the different states of the materials, how much you start with, the values. For instance, the products, they have a certain value at the end. There are materials that are undesirable. You want to minimize them. Here you can see the graph in terms of the transitions from, so the materials going to some reactions that then result in other materials and so on. So you can see these connections. And in this case, is Groby being used to solve the problem. And here you can see the state of inventories over time, batch units, and here is the schedule being used to solve the problem. And let me see what else I can show. I can just quickly show, since I showed the stochastic facility location, we have a stochastic facility location app here as well, where you can see that the model from ChatGPT is here. But in the app, in fact, we use a model that was written by ourselves because we use Bender's decomposition to make a model able to scale further. And one thing that you can also see here is that this connects to Nextmove, which is an easy way for you to also deploy your applications. So essentially, we lower the barrier to model and to build these applications. And also, if you are alone and you don't even have a team to take care of deployment, and you need to deploy a big application, that can also be made easily using AMPL and combined with Nextmove. Just to finalize, let's go very quickly into some resources. So if you want to accelerate even faster, so AI already allows you to move a lot faster than without it. But if you want to move even faster, you can contact us. We provide consulting services. So we can build model and apps for you. We can help and fix finishing what you might have already built. Let's say you built something using AI. You have some questions about how good is your model, what could be done to make it better, what kind of modeling techniques could you use to improve performance, and so on. So you can ask this type of questions. We can build entire solution for you. We can also provide training. Let's say you have an entire team that wants to get up to speed into optimization, especially if in your industry, in your company, nobody is really doing optimization. It might be worth it to start looking into it, because especially if the competition is doing that, you might be in trouble soon, because optimization is quite powerful and it can lead to substantial to a substantial edge over all other competitors that are not using it. So contact us here, ampl.com/services, if you want some help. And if you want to learn on your own, here are some resources. You have the community edition license that you can use, even if you are already in a company. It's for personal use, and you can just create an account and get access to it. You can start building applications right away using AMPL and open source solvers. You can start commercial solver trials at any point. And here is Streamlit, Mobook, and Collab. And here at the end is the modeling guide for MP-based solvers, where you can see in detail all we have for modeling with this type of extended syntax. That's it. Thank you.
Thank you, Bob and Filipe, so much. That was wonderful. And so we have about 14 minutes now for questions. So let me open this up and I will just go in the order we received them. The first one we have is, what would be the best way to use AI if you have a model in Solver in Excel and want to transform it to a Python script? Have you tried this?
Not that in particular. If the model is already in some syntax that resembles mathematical problem description, asking for ChatGPT or some other tool to translate it should work fairly well. One of the things that even happens to work is, for instance, you take a screenshot of a math book with equations, and you can ask it to translate from there. So I will suppose if anything that you have there resembles a mathematical formulation, it should be possible to translate into a model, at least to an initial version of a model that can then be fixed and improved.
Thank you. And then we have, might combine these two. We have applications of Python in healthcare and AI applications in biomedical science.
So in healthcare, so in Mobook, we have some for shift scheduling that should apply to healthcare, but we don't have much in terms of particular applications in healthcare other than scheduling, I think. But Mobook is likely a good source to check other applications. At least in Collab, I don't think we have anything in particular there. Yeah, but it is something that we can start looking into, and especially start asking ChatGPT to write some models for us.
Next one, we have optimization models for supply chain planning often involve quite significant amount of input data. Can you recommend a framework to implement large-scale scenario data editing and solution display/visualization? Is Streamlit suitable for that, or better to look elsewhere?
I will say Streamlit can handle that. So essentially, Streamlit is quite generic, and of course, it depends on how much data you are looking at. But if you are still at a scale that you can work with it in Python, you are safe to use Streamlit. So it's not going to add much overhead on top of what you already have. So if you are able to do the data manipulation you want to do using pandas or polars and so on, you should be able to use Streamlit on top of it. Just don't like display really huge tables. That kind of thing can be problematic. So, but other than that, it should not be the bottleneck.
All right, next one we have is, can you expand on how AMPL versus Python-based tools languages can hold a returned solution in session, allowing constraints to be added or dropped, or some data to be changed and then sent back to the solver in a more efficient way than if no such session were present?
Okay. So we have solver interfaces with callbacks that also allow a persistent solver object. They are called AMPL-S. So essentially, you can, instead of solving, you export one of these solver objects that you can have new constraints or define callbacks and then solve. And that is persistent. that can be used, for instance, for stochastic facility location. And we have an example on Colab for that.
Next one we have here is, I like AMPL file in parentheses .mod is separated from the data. I think it has great advantage in LLM for optimization modeling compared to Gurobi file. Have you ever compared how ChatGPT or other language models perform generating .lp and .mod for mid to large optimization problems?
In terms of generating models, because generating an LP is different because it's more scalar. We have not done that so much. In terms of generating the kind of AMPL models in which you have index variables and so on, it is quite powerful. We have also seen it being fairly reliable, also generating some regular models using Python tools directly. The main difference there is that the ability to be able to validate your model. I think the biggest benefit there when you are generating a model in AMPL is that you have a very compact model that you can validate quickly, because as I mentioned, it is risky to trust these models directly. There are some people that even build applications that you are just talking to the chatbot and it is running some optimization behind and then just showing you solutions. But I think that can be risky because it might hide the fact that there might be a minus instead of a plus somewhere and your company might go bankrupt.
Yeah.
So,
yeah, just let me add that the a .lp file is an explicit description of every single constraint one at a time. If you have 10,000 constraints, there are 10,000 lines in there. So it's very different from a mod file, which is a symbolic, very compact description of what your model is, and the data is somewhere else. The LP file has all the data in it. So there's not really a direct comparison between the two. If you ask Gurobi, they'd say, well, write it in Gurobi Pi. And they only use LP for debugging.
Thank you. And then the next one we have is, when using AMPL's automatic linearization, is there a way for the user to see the linearized constraints that are passed to the solver?
yes, there is a reformulation explorer. It's one of our Streamlit apps. So if you go to ampl.com/Streamlit, there is a reformulation explorer app there, and it has instructions how to generate the reformulation graph that you can then upload and see a constraint from the original model, how it became, what it turned into in the final model. But in case you have questions about how something was reformulated, and especially if you believe that something can be do better, contact us, because we are always looking for even further opportunities to produce even better models.
And the last question we have here in the Q&A is, you seem to mostly be using ChatGPT. Have you explored any of the Gen AI tools that have been built specifically for code generation or conversion, and whether those perform better than ChatGPT?
Yeah, I have tried other tools. The main thing that happened is that other tools, they often come up with some language that resembles AMPL, but is not exactly ready to just use. That is the main thing. So AMPL is quite natural. And I believe that's why these tools then manage to quickly see the relations between the mathematical equations and AMPL syntax. But most of the other tools, they imagine some other language in which, for instance, instead of curly brackets, you have parentheses. So some small things like that don't produce models that you can just copy and use. They can still produce good models there, but you need to do some work to fix them. Yeah, but ChatGPT seems, from all the ones that I tried so far, seems to be the only one that reliably produces good models often. ChatGPT 4. With the other versions, it is not as reliable.
We had one more pop in. Payroll is becoming a big deal now. Is Python application in this area to interface finance/HR feasible?
I could not hear what was the beginning.
It's payroll is becoming a big deal now. Is Python application in this area to interface with finance and HR feasible?
Yeah.
is table.
Payroll.
Table-
Yeah,
Let's
Sorry,
Yes.
see.
payroll.
Payroll. Ah, okay.
yeah.
Not the question.
See
I
here.
can see the Q&A.
I can pop it in the chat too.
Yeah,
Yeah, if you
Yeah.
could do that. Yeah, because
you
chat I can
click-
see, I cannot shoot Q&A. Okay.
you
Just
can
add it in
click
there.
Q&A and you'll see it. I
Okay.
think.
Payrolls become.
Yeah, I don't know. We should,
No,
yeah,
I don't see,
yeah,
but an optimization problem related to payroll, like
yeah. So maybe,
optimizing stuff and so
yeah,
on.
yeah. Yeah, maybe we should take that one offline and
Yeah,
discuss it further.
That sounds good. And that was our last question in the Q&A.
Okay.
Any final thoughts from Bob or Filipe before we wrap up?
maybe just one thing, just to mention that everybody about the risks. I think the main risk is to not pay attention to these tools. So pay attention to the competition. Without them, you might be in trouble.
Yeah.
Wonderful. Thank you
Yeah.
both so much for being here and presenting. And on behalf of Informs, thank you to
Yeah.
everyone for joining today.
Mhm.
And we will be sharing this recording with everyone once it's processed and uploaded. I'll send out an email with the link to that. And we hope everyone has a wonderful rest of their day.
Okay. Thanks, everyone.
Thank everyone. Bye.